Okay, this is chapter 6.3, medians and altitudes of triangles. The essential question is, what conjectures can you make about the medians and altitudes of a triangle? So what you will learn in this chapter section is you will use medians and find the centroids of triangles. There's a new definition, centroid. And you will use altitudes and find the orthocenters of triangles. So altitude and orthocenter, two other new things. So let's take a look. Okay, so before we get to an example, we first have to talk about a theorem that we're going to use in that example. So using the median of a triangle, okay, here's the vocab, is a segment from the vertex to the midpoint of the opposite side. So if I look here, B is the vertex and F is the midpoint of AC. Notice the 3 marks, that means midpoint. These two pieces are congruent. And then if you draw a line from A over to the midpoint of BC to E, and if you draw a line from the angle C over to the opposite side AB to a point D, which is the midpoint of AB, then you have 3 line segments that go from a vertex to a midpoint meeting at one location, and that's the median of the triangle. The point of concurrency is called the centroid inside the triangle. So the median of a triangle is just one of these lines. So 3 medians of a triangle meet at the centroid. So the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so it says AP is 2/3 AE. So AP is 2/3 of AE. So that means that if AP were 2, then PE has to be 1, because the whole thing now is 2 plus 1, which is 3. Therefore, AP is 2 out of the total 3. And so it's 2/3 of the whole thing, AE. So AE is 3, AP is 2/3 of 3, and PE is then therefore 1/3 of AE. All right, so that works for all 3 of them. So it's a 2-to-1 ratio, if you will, 2/3. Okay, so we're going to use that in example 1. Okay, example 1, using the centroid of a triangle. In triangle RST, okay, this triangle, point Q, which is right here, is the centroid. So with that information, then we now know that these line segments that meet at the centroid are called medians. And since they're medians, then we now know that this SQ, the longer piece, is 2/3 of the whole thing. Okay, so here's the whole thing. Don't want to make that thick. Let me make it thinner, actually, so I can still see the yellow. So this is the whole thing. SW is all of it. SQ is 2/3 of it. So now what we're going to do is we're going to answer this question by saying that SQ, this longer piece of the median, SQ, is going to equal 2/3 of the whole median, SW. And I'm going to go back here, and that's what they're talking about here. So notice AP. AP is this long segment of the whole thing, and it is 2/3 of the whole thing. So you say AP is 2/3 of the whole thing, AE. So now I have SQ is 2/3 of the whole thing, SW. Well, we were given SQ is 8. So here's our formula. So you write a formula, SQ equals 2/3 of SW. Then you substitute the given. So SQ is 8 equals 2/3 SW. And in order to get rid of a fraction, you multiply by its reciprocal, 3/2. And what you do to one side, do to the other. So 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1 SW. And this will give us the length of SW. And divide first. If 2 will go into 8, do that. 8 divided by 2 is 4, 4 times 3 is 12. So 3/2 of 8 is 12, and SW is 12. So therefore QW must be 4, because 8 plus 4 equals 12. Okay, so that is, and it said, and find SW. It says find QW and SW. So QW is going to be the total SW minus the longer piece that they gave us. So if I wrote that, I could say QW equals SW minus SQ. And I was given SQ to be 8. We found SW to be 12. So QW equals 12 minus 8. QW equals 4. So now you should be able to do problem numbers 3 and 4 in the exercises. Okay, example 2 is finding the centroid of a triangle. It says find the coordinates of the centroid of triangle RST with these given vertices. So the first thing I am going to do is plot the points. R is 2, 1. So I go over 2, up 1. Here is R. S is 5, 8. Go over 5, up to 8. And this is S. And T is over 8, up 3. So I'll put T right here. So let me connect these. So I'm just going to go get a segment, and I'm going to make it a little bit thinner, and I'll make it, I don't know, blue. So I'm going to draw a segment from R to S, S down to T, and T back to R. Let me just fix this a tiny little bit. It's off a hair. Okay, and this over like so. Okay, so you get the idea. There's triangle RST, and let me label the coordinates. This is the point 2, 1. This is the point 8, 3, and this is the point 5, 8. Okay, so what have I just done? I graphed RST. That's the first thing you do. Step 1, graph it. Done. Step 2, we want to find the midpoint. We want to use the midpoint formula to find the midpoint of RT, and we'll call it V. So I want the midpoint of RT, and we're going to call it V. So V equals, and remember midpoint is X sub 1 plus X sub 2 divided by 2, Y sub 1 plus Y sub 2 divided by 2. It's the average of the X's, average of the Y's. So I'm going to substitute in my given. So I'm going to just write what I already know. And X, so I'm looking for the midpoint of RT. So X1 is 2. And X of 0.2, which is T, is 8. So it's 2 plus 8. Add the Y's. 1 is in the first point. And in the second point, our Y is 3. So that's plus 3. So my V, my point V is going to be at the point 10 over 2, 4 over 2. And then we simplify. 10 divided by 2 is 5. 4 divided by 2 is 2. So I go over 5 up 2, and this is my midpoint of RT, and I'm going to call it V. Okay, so far so good. Graph the triangle with the given points. Find the midpoint of this side by doing the midpoint formula on the vertices of those two endpoints of that side. So now we know that we have, let me draw it. We now have this line segment right here. And I wanted it green, so let me switch that. Okay. So there is our median. Okay, let me go back. These are new definitions. The median of a triangle is a segment from the vertex to the midpoint of the opposite side. So that is a median. Okay, this is a median. We know the centroid because it says find the coordinates of the centroid. So let me highlight that. What are we trying to do? We're trying to find the coordinates of the centroid. All right, so remember this is 2/3. So I want to find the distance of this segment. So V is at the point 5, 2. So I should label that. V is 5, 2. So now I have 5, 8, 5, 2. The X's are the same. So it's a vertical line. So the distance is just simply the difference in your Y's. So S V, the length of SV equals 8 minus 2. So all I'm doing is taking my y's, 8 minus 2, so that's a distance of 6. So the length of SV equals 6. Okay, so the centroid is 2/3 of that. So the centroid is 2/3 of 6, which equals, well, 6 divided by 3 is 2, times 2 is 4. Or you could say 6 times 2 is 12, divided by 3 is 4. So the centroid length is 4. So I'm just going to start at 8, and I'm going to count down 1, 2, 3, 4, and right there is my centroid, and that is the 0.5, comma 4. Okay, find the coordinates of the centroid. There they are, 5, comma 4. So the answer to this question is the 0.54. So after doing that, you should be able to do problem numbers 15 and 16 in your exercises. All right, using the altitude of a triangle. So if you have a triangle and you draw a perpendicular line from somewhere, if it's an acute or a right triangle, or I'm sorry, if it's an acute triangle, then the altitude will be inside. If it's obtuse like this, actually, it could be obtuse if this is rotated. But if you have a triangle like so, and you draw a line down and you're in the interior, then the altitude is inside the triangle. But if you have an altitude coming from like this, and this is an obtuse triangle, your altitude would end up being outside the triangle, but the height is still going to be a perpendicular distance from the vertex down to the base. So an altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So here's your vertex, draw a line straight down to the opposite side, or if you draw a line straight down to a line that contains the opposite side, you have to extend that line out. All right, so the core concept for orthocenter. The lines containing the altitudes of a triangle are concurrent. Okay, in other words, if I drew an altitude from A, an altitude from B, and an altitude from C, all three are perpendicular, and they will meet at the same point, meaning orthocenter of the triangle. So another word for perpendicular is orthogonal, and that's where the word orthocenter comes from. The lines containing AF, BD, and CE meet at the orthocenter point G of triangle ABC. Okay, so there's an altitude and there is orthocenter. So let's take a look at the next example. Okay, so here's example 3, finding the orthocenter of a triangle. It says, let me highlight it. It says, find the coordinates of the orthocenter of a triangle XYZ with vertices X. So I'm going to start right there, plotting these points. X is -5, -1, which is right down here. Here is X. Y is -2, comma, +4. Y. And Z is over 3, down 1. Okay, so let me connect these. Here's segment XY. Here's segment YZ. And this is segment XZ. So there's my triangle. So then I want to draw. So there's the graph of the triangle XYZ. So that's step 1. Find the vertices. So there's 3 vertices and graph them. That's step 1. All right, so now I want to switch colors and I want to make this a line. And how about green? Okay, so here's what we're going to do here. We are going to draw a line. What just happened? I just chose a line and I made it green and then it ignored me. Okay, so anyway, here is the line. This is a line going through the vertex down, and I want it to be perpendicular. So I want to find the equation of that line. So the equation of that line, since it's vertical, that's the easy one. It is going to be this green line right here, let's use green, it is going to be the equation x equals -2. That is the equation of this segment or line. Okay, x equals -2, vertical line. Okay, the next thing we want to do is find the equation of the line that contains the line from x to z. So there is going to be another line segment that's going to be perpendicular to this. I need to find the equation of it. So before I draw that, because I can't draw perpendicular, this one was easy because xz was horizontal. Therefore, the line going through y is going to be perpendicular or vertical. And that was easy. So all I have to do is show that that's 90 degrees, and horizontal line and vertical lines intersect at 90-degree angles. But now I don't know where to draw this. So here's what I'm going to do. I'm just going to show you what it would look like if I were to draw it and not know where to draw it. So I'm going to go through x like so. But that, I don't know if it's perpendicular. It actually doesn't look like it is. So I would have to rotate this until it appeared to be approximately perpendicular. And again, it's something like that. Okay, I'm going to leave that there for now. Actually, no, I'm not going to delete it. We do not do approximations in math. It has to be precision. So how do I do that? Well, I want to find a line perpendicular to YZ going through the point X. So what is the slope of YZ? Well, we have a point -2, 4, and we have a point Z, which is at 3, -1, and slope M equals, and I'm going to call that, and I'm going to show you how to do you would say M, the slope of line segment YZ, the slope of segment YZ equals, and slope is y2 minus y1 divided by x sub 2 minus x sub 1. And therefore the slope is y2, -1, minus 4 divided by x sub 2, which is 3, minus x sub 1, which is a -2. So when I simplify this, I'm going to get -1 minus 4 is -5. And 3 minus a -2 is 3 plus 2, which is 5, which equals -1. Okay, the slope of a perpendicular is equal to the negative reciprocal of the other line. So I want a slope of +1 since this one was negative. This is a slope of -1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1, and so on. This slope of the new line segment is going to be +1, and I know a point it's going through. It has to go through the point -5, -1. So we also have a point -5, -1. Well, the equation of a line is y equals mx plus b. And I have a y, it's -1. I have a slope, which is 1. I have an x, which is -5. I just don't know what my b is, but I can find it because that's the only unknown. So -1 equals -5 times 1, which is -5 plus b. Add 5 to both sides, and we find the y-intercept. And b equals 4. So the equation of my line is going to be y equals the slope 1, x plus 4. There's my equation of my line. Now I'm going to draw it because I know it goes through here and I know the y-intercept. So then I'm going to pick a line and I'm going to draw it in. I'll do red this time. So I know it's going through x and it's got to go through the point, the y-intercept of 4. So I want it going through here and here like so. So there's the y-intercept 4, and there it is going through my vertex right there. And so now I can confirm that this is perpendicular like so. So now there's my point. And we already know the third one is going to go through that point as well. So there's no need to do a third location or a third line. I can find the slope of this line, do the negative reciprocal, use 3, -1, find the slope of this line with the y-intercept, but it's going to go through the same orthocenter because all three angles do, or all three medians go through the orthocenter. So find the coordinates of the orthocenter. We just found it, -2, 2. And that's the answer to this problem. Okay, hopefully that made sense to you. This one was easy because it was perpendicular, but if it wasn't, then you just have to find the slope of two sides and the y-intercept like I did here. So after example 3, you should be able to do problem numbers 19 and 20 in your exercises. All right, example 4 is a proof. Boo. Proving a property of isosceles triangles. Okay, prove that the median from the vertex angle to the base of an isosceles triangle is an altitude. So we're starting with a given. Let's given that triangle ABC, prove that the median from the vertex angle to the base of an isosceles triangle. Okay, so now we have an isosceles triangle. So we're given triangle ABC is isosceles and with base AC. So we're just going to name it base AC. In the triangle ABC, B is the center letter. So let's call that our vertex. So A, B, C. B, the vertex, A and C are base angles. AC is the base. BD, therefore, is the median of base AC because the marks here show those two congruent. So BD cuts AC into two congruent pieces. We need to prove that BD is an altitude of triangle ABC. So what is an altitude? Well, let's go back. An altitude is a perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So what we need to prove here is that this BD is perpendicular to AC. All right. So the first thing we want to do is legs AB and BC of an isosceles triangle are congruent. So AB is congruent to BC. Okay. And the reason is because it's isosceles. Okay. AB is congruent to BC. Isosceles triangle. Okay. CD and AD are congruent because BD is the median. So I can say CD, segment CD is congruent to segment AB. Okay, definition of median. So that makes this congruent to this. Okay, median. AB is congruent to BC because of the definition of an isosceles triangle. So now I have a side and a side. So I know this is a side, this is a side, this is a side, this is a side. Do I have a third side? What am I trying to prove? Okay. And so there it is. BD is congruent to itself. Reflexive property. Okay. And so now triangle ABD. So now we can say triangle ABD. Triangle ABD is congruent to triangle CBD. And the reason is, mark this, the reason is side, side, side triangle congruence. All right, so now I can say angle ADB, this angle here is congruent to, so angle ADB is congruent to angle CDB. Okay, why? Well, corresponding parts of congruent triangles are congruent. Okay, so then once I say that, angle ADB and CDB are linear pairs. So angle ADB and angle CDB are linear pairs. Okay, AC is a straight line. Two angles forming it are linear pairs. And now since they're congruent, they both have to equal 180 degrees because if this angle is half of 180 and this angle is half of 180, then they're both 90. So now I can say that angle ADB and angle CDB are right angles. Okay, and since they're right angles, I can now say segment BD is perpendicular to segment AC. Okay, so by definition, let's go back again. An altitude is a perpendicular segment from the vertex to the opposite side or to the line that contains the opposite side. Okay, so BD is perpendicular. So now I can erase these marks here that I made just as arcs. And now I can conclude they're both 90 degrees. So BD is perpendicular to AC, therefore it is an altitude. Prove the median from the vertex is an altitude. Okay, so that's how you would prove that. So now that this example is done, you should be able to do problem number 29 in your problem set. Okay, concept summary, segments, lines, rays, and points in triangles. So we have a perpendicular bisector. Perpendicular bisector cuts the base into two congruent pieces and is 90 degrees. Point of concurrency is a circumcenter. And I'm not going to go through all this. I'm just going to read the three here. Angle bisector, these two angles are congruent because it cuts it in half. And that point of concurrency is an incenter. This is a median. Okay, a line that goes from the vertex to the side opposite, cutting into two congruent pieces. That is a median. And they all meet, if there were two other medians, they would meet at the centroid. And there's an example. And the altitude is a perpendicular from the vertex down to the other side. And if you did three altitudes, they meet at the orthocenter. So review these concepts, get familiar with these words and where they come into contact, where they intersect, and you'll be all set. All right, that brings us to the end of chapter 6.3, fairly short chapter section. A lot of vocabulary words though, so use your flashcards, learn those terms, and do these exercises. And 55 through 58 are review problems. Okay, thanks for watching and have a great day.